So this is one of the tricks that they'll use in data sufficiency to steer you in the wrong direction. We don't necessarily need x or y. We need x squared minus y squared. So this is different than solving x, and it's different than solving y. We need to solve for the difference of the two when they're squared. So if we look at this situation, both of them are placed in terms of t initially. And statement one is going to allow us to solve for two values of t because it gives us t squared equals 9. Now that means that t equals plus or minus 3. And this would look insufficient initially, but we need to plug it back in to see what happens if we use 3 and if we use negative 3. So if we use 3, then x becomes 2 times 3, which is 6. And then we'd have 6 squared minus y, which is 3 over 3, which would become 1. So that would give us 1 squared. So here we are going to get a positive value of 36 minus 1, which is 35. Now notice if t is negative 3, we're going to get negative 6 squared, which is the same as 6 squared. And we're going to get minus negative 1 squared, which is the same as 1 squared. And that means we're also going to get 35. So statement 1 is sufficient. I know the answer to the question is 35, regardless of which of these two answers for t we end up with. Now, statement 2 is very definitive because when we have an odd exponent, we know exactly what this number originally was. It's the cube root of negative 27, which is negative 3. When you square a number or take it to an even exponent, you lose the original sign, so you have two considerations. But when you take it to an odd exponent, you keep the original sign, whether it was positive or negative. So there's only one value here. Once we have t, it's guaranteed we can solve both x and y, so we can definitely solve this. I won't go through that process. We've already solved it over here. And that means it is also sufficient. And this leads us to answer choice D. So a lot of people look at statement 1 and say, well, there's two potential values for t there, so probably not solvable. But that's almost too obvious. Make sure you plug them in and check to make sure that you know whether or not they give you the same value out, which in this instance, they did.